So thank you for coming. Today we're going to be talking about indexing and searching content that is in audio and video files, and we will see how that works. So basically we'll start off by stating a few of the talk objectives and then move around on the agenda. So basically I wanted to do this talk to use the audio and video indexing as a use case so that I can explain to you guys how basically all those parts are needed so that you can index audio and video content, and also show how easy it is to add new transformers into the repository, how you can add that into a subsystem and how that works, and what benefits you can get from using subsystems. So the focus here is not on having a perfect recognition accuracy for all videos. It's showing a working demo that we will use to explain how all those parts work. So basically, as I said, we will start off with a demo, a very short demo, and then we will talk about all the various parts that are needed to make that work. Basically, how we can extract the audio and transform that into text, how we can then integrate that transformation in the repository, and we'll talk about also some of the new features around transformations that came out around 4.2 and later. You might not be aware of all of them. And we will then talk about how we can integrate that transformation into a subsystem, and basically what is it, what benefits you can get from organizing your code and your config into a subsystem. So we will start off with a very small demo. Basically what I will do is that I will take a video file, I will drag it and drop it into the repo, nothing special, and then we will wait a bit, like 10 seconds, and search for some speech that is spoken in that video, and you'll see that we'll get it in the search results. Actually, I would like it like it was because I can see the screen better.
Oh.
Huh.
I think you have a remote mouse, so if you want to come over.
Oh, that's fine. Thank you very much. Okay. Okay, so let's connect. And I will basically create a site, just nothing special. I will remove that, I don't need it. I will go to the document library, and I will take a video file here and drag and drop it into the repository. So let's see. There you go. We can open it up just to make sure that it's actually a video file.
Blessed is he who in the name of charity and goodwill.
Okay, so I think we all know when that comes from. So basically, you can go back and search for charity, for example, charity, and it comes up as a search result. And as you see, I didn't add the word in any metadata. It's been indexed, and I can search for the text. I can do that as well with, for example, an audio file. Let's see if I have someone here, some video file here. But basically, it will be the same. So let's see. Okay. I will go back to the document library and just drop a audio file, for example, that one. It will be the same.
Hi, I'm Brian, one of the available high-quality text-to-speech voices.
Whatever. And let's search for quality, for example. And it comes up. So now we'll go back to the presentation and figure out how all of this works. So let's go for it. There you go. All right, that's the screenshot just for the guys who will download the presentation afterwards. So basically, this presentation will be organized, as I said, in 3 parts. One part will be how can we actually extract the text from the audio file or the video file, how we can then integrate that file or that script into the repository as an external transformer, and then how we can basically package that transformation into a subsystem. As you will see, all of this requires absolutely no code. It's only config. So basically, you will see that it's quite easy to add new stuff in the repository. So the first part is basically how can we extract the audio. So it will be 4 parts. How can we detect the mic type? How can we extract the audio? How we can pass it through PocketSphinx, which is the tool that we are using to do the actual conversion from audio to text, and then we will see how we can return that text to the repository. So the first part is MIME type detection. That is handled in a little shell script that is called by the repository, and I'm using a tool called exif tool that is basically telling me is it an audio file or is it a video file, because then you need to handle it a bit differently. So that's very simple. Then we will do the audio extraction. For that, I am using, if it's a video file, I will be using ffmpeg to basically dump the audio out of the video so that I can use it afterwards. And if it's an audio file, even though it's already audio, you will need to resample it to a proper sample rate, as we will see later, as it is quite important for PocketSphinx to have the same sample rate, that to be configured with the same sample rate that the file or the audio file is. And for that, I'm using basically a tool called SOX. So it's very simple. The shell script is like maybe 10 lines long, and that's all there is. So we'll see later why is it important to have the same sample rate. As I mentioned, for speech to text, I am using a tool called PocketSphinx. Anyone here familiar with PocketSphinx? One guy. Okay, that's all right. So that's good. I put that slide in. So basically, it is a tool that you can. That is part of a larger project that is developed by the Carnegie Mellon University, and you can use that basically to convert a body of audio content into text. We will see how that works in a bit later. And it is nice because in that use case, I wanted to have something that is not relying on anything online. I know there are many alternatives. Google has one, Amazon has one, etc., etc. But I didn't want to rely on the network. So that one works completely offline, and it's not huge. It's only a few hundred megabytes, depending on the config. So that's quite easy to add in any repository, even if the repository is not connected to the internet. So that's very sufficient for a demo. As you've seen, you can just drag and drop a file, search for text, and it works out. So basically, PocketSphinx to work, that is the important part. It needs, as you would think, some utility parameters that are not really interesting, as like the working directory, what's the input file, what's the output file, what's the input type of the audio, like basic stuff. But the most interesting part is the last bit. Basically, it's called an engine configuration file, and it works with three parts, which we'll talk about in the next 3 slides. First, there is the acoustic model, which is also called in math terms hidden Markov model, if you want to look it up on Wikipedia. There is also a pronunciation dictionary and a statistical language model, and we will see how these 3 parts work together and what basically they are. You will see that actually all the 3 files need to work together. So if you need to change the config for some reason to index another language or to index differently, usually those 3 files need to work together, and you will see exactly why. So the first part is what is called an acoustic model. So basically, in one sentence, it tells us how likely is it that a specific sound is followed by another sound. So that's really the one sentence definition. It contains, for a specific language, all of the statistical probabilities that a specific sound, or what in specific terms is called a phoneme. So basically, you break down all the specific sounds for language, and in the English language there's about 40, and you just run through all the possible sentences that is possible in the English language and make up statistics about how that specific sound is likely to follow another sound. That is basically how that works. And it is more complex than that, because every sound needs to be matched against all the others. So every specific sound has a specific set of probabilities. And basically how that works is using, as I mentioned, a hidden Markov model, which I will spare you the specific math details, because that is quite impressive and intensive. But for those of you who studied regular Markov chains at university, a hidden Markov model is basically a state machine where the output depends on the state of the previous step. So in our case, it means that basically the sounds depend on the likelihood of previous sounds. So that is why it maps very well with that math concept. So in a sense, the probabilities of the next sounds or the next words are influenced by the previous one. For example, if you have a sentence that has the word house in it, it's unlikely that you will have the sound, I don't know, dashboard or whatever in it. And there are two additional parts that you needed to actually use this because it's not sufficient on its own. You need to have basically a list of all the potential words that is possible in a specific language broken down to specific sounds for that word. And you also need, it is not sufficient in itself because you might want to have, if you have, for example, several matches for a potential word, it might make sense to match it in context. So then you might want to look at the previous word that you've identified or the previous two words that you've identified so that it's easier to find out what actually the word is among a set of candidates. So the second part is what I mentioned, as I mentioned, the pronunciation dictionary. So basically you take all the words in a specific language, break them down into sounds or phonetic sounds, and convert them in a file. So if I'm making any sense here, the last word should be, someone should be able to tell me what that is. Sorry? Good. At least one of you is following it. So and the last part, as I mentioned, is basically, let's say you have identified several sounds. You aggregate them up. That makes a word. And since it's not a perfect science, you might have multiple candidates for a specific word that you've identified. And that is why you need that part, because you will be able to find out in a specific language, is that word more likely to appear than that one? And based on that, you will be able to determine statistically that this word is probably the one that you want. And there are basically two types of statistical language models. One that is called a trigram and one that is called a bigram. So basically, it depends on the amount of words that you consider in the previous steps. So if, for example, you are only considering the previous word that you've identified as a probability, then it's called a bigram because you're only considering two words. If you're considering the two previously identified words, then it's called a trigram because it's like two words that are previously identified and a new one. And that allows you to basically constrain the search based on probabilities. You will see that, for example, the word, I don't know, apple is unlikely to follow the word cat, for example. So basically, to summarize that part, so we take the audio file, we break every word, so if, in a sense, every blank separated audio bit, you convert that into elementary sounds. That's the first part. That's called break it down to phonemes. Then you look that up into the dictionary to find out multiple words that would approximately match that actual word. And then you use statistics based on the previous word or the previous two words to select the proper candidate. And then you just return that word to the calling script or, in sense, the repository. Just one bit of warning about this, it is absolutely critical that you select all the three parts to match your actual content. So there is something, there will be something called broadcast news in this tool, which means that you will be indexing audio that is basically someone talking in a relatively slow voice with no background noise. So that's easy to identify. If you want something that is more tailored to your environment, you might want to consider training the engine against your own set of content. If you have a giant corpus of like millions of audio files that are not really standard, you can train the engine to recognize your own content, and then you will have better results when you are indexing similar content. So the second part is going to be a bit less complex. It's going to be about how can we integrate that script that does all the work into the repository, and what are the new features in that area in the repository. So what is the goal of transformation? I'm assuming most of you are familiar with transformation. Basically, it is you have a source format and you want to transform it to another target format. Either you want to do it directly, so you want to convert, for example, a Word to a PDF directly, or you can do that indirectly, for example, a Word to a PDF and then PDF to Flash, for example. And we can basically do that using either a command line transformer, which requires no code, only config, which is what I'm doing in that example, or you can use any code, Java library, write a script, anything that you can integrate in the repository as a transformer. For example, in the repository, the standard use cases are, for example, thumbnailing. Thumbnailing requires that we can transform the source content, whatever it is, into an image. And full text indexing basically means, without going into details, is that we need to get the source content, convert that into text, and then do some work on that text so that the indexer can index it. Some additional transformation features that you might not be aware of that have been introduced recently as of 4.0 and 4.2. It is, for example, the transformation size limits. So for example, if you want to prevent someone from uploading a 50 megabyte Excel file that is going to throw the repository into a long queue of transformation, you can say, I will not allow that source to target transformation if the file is more than 10 megabytes, for example. And you can do that per MIME type. So if you don't need to set a global limit, you can say, for that specific transformation from, in that case, for example, video to text, I'm not allowing transformation if the video file is more than 100 megabytes, for example, because it's going to fry your server, for example. You can configure the number of space and the spacing of retries. For example, if for any reason the transformation failed at one point when someone uploaded the content, you can say how much time I'm going to wait before retrying and how many times I'm going to retry before giving up. That is quite useful because sometimes you have a transformation that doesn't work for any reason. Something's not on the file system. There's no space on the file system, or too many people are doing transformation at the same time. Then you can configure how long you're going to wait to retry, basically. And there are also several factors that can be considered for selecting the proper transformer. We will use a priority that you can define. You can say, if I have two transformers that are doing the same transformation, that one is usually better, so I want to prioritize that one. And if we have two similar routes that have exactly the same priority, then we will try both 3 times and figure out which one is the fastest that we will keep using for the rest of the life until you restart the repository, for example. You can see on the wiki or on the documentation portal more examples about this. Something that is also quite nice and that I used in that case, in the demo, is that for some of you, maybe you were used to add transformations through Spring config. Has anyone done that before? What? Andy, you don't count. So yeah, so basically, you can now do all of that through properties. You don't even need to do the Spring config. You can just specify through what we call composite properties what is the new transformation that you want to support. So you just say, this is now the MIME types that I support from this to this, and we'll figure out automatically what transformer to use. You can either use, in the example, I'm using MIME types, but you can also use file extensions if you would like to. There is also a new feature that is quite interesting as of 4.2. You can also specify complex transformations. That means using an intermediate MIME type also through properties. So you do not have to write the whole Spring config and say, this is my transformer, let's go this way and that way, and using that tool, etc., etc. As I mentioned in that example, for example, if you want to have a gallery view of video, you can just add that stuff. That will say, I'm creating a new transformer that will use my own custom transformer, which is video to thumbnail, then go to PNG through ImageMagick, and then convert that into JPEG. And all of that, you don't need anything else than just simple properties, which is quite nice. If for any reason you have something going wrong in the transformation, or it's not doing what you expect it to do, you can add that in the log4j config, and it will dump absolutely everything about the transformation that's going on. So it will see, it will tell you what transformer were considered or not considered depending on the limits that you've set, how long it took, what is the potential error if there is an error, and you can basically really easily figure out what happened or why didn't it do what you thought it would do. And if you set to trace level, you have even more debug. If you have a very specific problem, well, it will do absolutely everything that's going on, the command line, etc., etc. And you can see that wiki page if you want more details about that part. So in our example, if we apply all that I've just mentioned earlier, there's absolutely no Java code. It's only config that I've just mentioned to add that ability to transform audio to text. So I'm basically extracting the audio, getting the text, adding that in a transformer in the repository, and returning the text that Solar will natively index. So the third part is going to be, okay, now we've defined our transformer, but it would be nice if we could package that into a subsystem, and we will see why just now. So basically, we'll talk about what is a subsystem, how we can integrate that transformation into a subsystem, what benefit would be to use it, how we can configure it, etc., etc. So basically, a subsystem has been introduced in 3.2. Anyone familiar with subsystems in the room? 1, 2, Andy, 3, 4. Okay. So, okay, interesting. So it's been introduced for quite a while now. It's been introduced in 3.2. So I think it's been a few years that it already exists. It really simplifies the configuration for advanced stuff. For example, if you have ever configured LDAP chaining 3 years ago, it is now way, way simpler. And that's because before 3.2, we had all of the Spring beans in one application context, regardless of what file it was in. So it was quite difficult to figure out if a bin already existed, what part of the application did it work with, how could you override it, etc., etc. It was really, really complex. You had all sorts of files everywhere with all sorts of beans, and you didn't really know how they interacted together. And now, what we have is basically a set of subsystems, meaning a set of child application contexts with their own set of beans that can, be cleanly separated, and you can cleanly package that so that your own private beans are not exposed to the entire repository, and you just expose a set of interfaces that you can use from the rest of the repository. And as you can see in the picture, basically now we have much more separated and cleanly packaged subsystems, meaning like you have one for all the authentication, one for the auditing, one for the transformations, one for synchronization, etc., etc. We decided to label the subsystems basically with two supplementary information. One is the category and one is the type. That means that you can further refine your packaging by saying, okay, that specific subsystem is going to be mapped or tagged in the authentication area. So for example, you will have one that will be the authentication subsystem that will contain the ability to authenticate to an LDAP directory, to a Kerberos server, to do NTLM, to do SSO, and all of that will be a type of that category. So that means that you can really easily, even on the file system, as you can see, you will have Alfresco /subsystems /category /type. So it's easy to identify where the relevant config is for that specific part that you're looking after. An interesting thing also about the subsystem is that automatically all of the config will be exposed through JMX. So if you ever used the JMX console before, anyone's used it? Anyone's used it? 1, 2, 3, 4, 5. Oh, okay. So basically, you can configure some stuff from the repository automatically and live. So you don't need to restart anything. If, for example, you want to disable the FTP server, or you want to change the name of the admin user or anything, you can do that live without any restart. And that is all because of the subsystems. There is nothing specific to do as long as you configure your code or your config to be compliant with the subsystem syntax. Automatically all of your properties will be exposed through JMX, and you will be able to modify them live without any specific additional work. So that's why that is one of the benefits of actually, putting your Spring config in the right place. That way you have all that benefits given for you for free. In our case, it could be, for example, that you want to index a different type of content through a different set of config files that we mentioned earlier. Well, you could actually, through JMX, go there, and we didn't do it because I don't have the time, but you could go in there and change the configuration and index differently without having to restart the repository or making any other changes. One thing that is important about JMX is that everything that you do is persisted in the database. So, for example, if you have modified the FTP server in the JMX console, then you will, even if you restart the repository, what you have done in the JMX console will take precedence. So, for example, if you if you forgot, or if you want to change that back to what the file says, then you can use the revert operation in the JMX console. That means that all of the persisted config that you've done for a specific area of the config through JMX will be forgotten, and upon the next start of the subsystem, which will be in a few seconds, you will get back the config that you've defined on the file. Just a bit about the subsystem config precedence, which is somewhat tripping up some of the people sometimes. As I mentioned, all that you changes to make in the JMX takes precedence about everything else. Then it is the stuff that you've configured in the extension directory. So you can have share classes extension subsystems and create your own config there, so you don't have to put it in the WAR or in an AMP. And then you have the default subsystem, which is basically the, let's say, the common configuration for a specific category of subsystem. So, for example, you could have some common config to configure to connect to OpenLDAP and to Active Directory, and only the part that is specific to each being in a type subsystem. Then, and that is the part that is important. That stuff takes precedence over Alfresco global.properties, even though most of the time Alfresco global.properties is the source of truth. If you have defined something in the extensions directory for a specific subsystem, that will take precedence over Alfresco global. And that is by design, because we want to have some config that might apply to everything else, except one specific bit of config that is for one specific subsystem. That way you can do it. If Alfresco global took precedence over the extension subsystems, then you could not define one thing that is specific in the extension directory. And of course, the last one that is used is basically our own defaults that we ship. So some of the current subsystems, as I mentioned, there is one that is called third party. This is the one I am using for that demo, which is calling all of the third party tools, which could be OpenOffice, it could be PDF to SWF to convert PDF to Flash. It could be any external tool that you are using to convert source content to target content. File servers is the subsystem that is now packaging all of the config about exposing the repository as an FTP server, as a CIF server, etc., etc. Authentication, I mentioned it. Synchronization is the one that is actually connecting to the LDAP, grabbing all the users and getting them into the repository for the name, the first name, the email, everything, and it's synchronizing periodically. And one thing that I didn't mention that is quite nice is that you can also chain the subsystems. That means that you can have, for example, a typical use case is authentication. In Alfresco, you can configure the repository to connect to multiple sources of authentication. You can say, I want to try the LDAP first, and if the user is not in the LDAP, try that other LDAP bit, and then go to Cabros, and then go to any other source of authentication. So that is really now easy to do. It's only one property. Now, before that, you had to configure all sorts of beans and everywhere in different files, etc., etc. So the benefits of using a subsystem is basically a much cleaner separation, as I mentioned, of all the config and all the code. It is easier to configure because now we have all the exporting of the configuration automatically, as long as you've put the Spring config in the right place. Monitoring, we didn't talk about it, but basically you can also export methods from the subsystems. That means that you could have some custom reporting for any reason. Let's say you want to have the number of logged in users or the number of documents or anything that is specific to your business. You can package that into the subsystem, export that into JMX, and then connect your JMX metrics to any other tool like Nagios or HP OpenView or anything that you are using in your organization. And that is quite easy to do. It's only one interface to implement, and you can export basically anything that you want. It's also easy now to basically swap in another implementation of a subsystem. Before that, you had to override all sorts of beans and disable beans and etc. etc. Now, if you want to say, for example, I will implement my own LDAP synchronization for any reason, you can add that in very easily and then say, now I am doing this one instead of the Alfresco provided default one. So as I mentioned, you do not need any specific code to use that. If you are using Spring config today, you can just move it around in the right place, and it will become a subsystem, and then you can decide what parts of that config is private to you and does not need to be known for the rest of the repository, and then what beans are needed for the rest of the repository as an interface. And you can, if you wanted, also package that as an AMP so that you can include that in the WAR if you have some additional code that comes with it. We will now do a little wrap-up. So basically, what we did is that we talked about how we can index that audio content, like in a technical sense, then use that command line transformer in the repository as an additional transformer, and then package that into a subsystem. That was quite a bit of content to go in 40 minutes, but if you have any questions or think you want me to go into more details, I'm happy to take any questions. Any questions?
How much time did you invest to set up this?
Sorry?
How much time, your personal time, in man days, to bring this up and running?
Oh, half a day or something. Yeah. No, maybe a day to research the whole thing and how does it work. But the config, as I mentioned, in the repository is really, really simple. It's only just a few config files. The part that took the very longest is actually researching the first part. How does that indexing work, and trying to find a tool that would suit my needs and trying to find the right configuration. But once I had that, once I had a transformer that was able to convert audio to text on the command line, which took me, I don't know, maybe a day or something. Adding it into a repository is extremely simple. You don't need any code. It's only config files. So it really is only a half a day or something. Anyone else? Don't be shy. No one? Well, I'm happy to take any questions here or at the experts bar. If you have any more, if you want me to go into more details about one specific part, if you have any questions, let me know.